Hi and welcome to day 15 of my 30 days learning to hack challenge. So today we are working on WIRESHARK and we are going to be using WIRESHARK to analyze packets on the network. So analyze losses of packets on the network and network latency. Alright, so let's get to it. I have opened WIRESHARK already. I had to come here, click on sniffing and spoofing. There you'll find WIRESHARK 2 there. Sniffing and spoofing, there you find WIRESHARK and then you click it to open. Okay, so when it opens, it brings you here. So on this interface, I'm gonna be selecting my network interface. So in this case, I'm just gonna pick any means whether it will detect on its own whether it's an internet or a Wi-Fi connection or whatever. So I pick any, selecting any, and then okay. So after selecting any, I'll set capture filter to post. .8.8.8.8. Usually this is the DNS server for google.com. Yeah, for Google's DNS server. So I'm just using that as a test. Just hit any post. Alright, so after that you click here to start capturing. So while that is on, I'll go to my terminal. I'll click on my terminal. I'll try to ping the host. It's not opening. System is really slow. So the next thing is to try to ping this guy. So let me ping. Okay. So remember I told you in Linux, when you ping, the results just keep pouring out until you're the one that has to stop it by yourself. So it doesn't stop until you stop it. So that is what just happened. I had to stop it using Control Z, which just suspended the. Okay. Alright, so let's minimize this. Let's go back to this guy. Okay. Showing us a lot of things. Now, okay, so let's analyze this. The request was being sent at 0.0 millisecond. It got a response at 0.1 millisecond, which is good. And what this means, TTL, time to leave, what this typically signifies is that this request was sent from a Linux server, basically. And then the response is also coming from a device that uses a high TTL, like a router or network appliance or that. So this is coming from a Linux server. The request was sent from a Linux server, so I pinged from a Linux server, and then the response was coming from a router of some sort, okay, or a network appliance. All right. So we've analyzed the ICMP ping responses. The next analysis we want to do is the DNS query response time. Okay. So what we'll do, we'll come here and type DNS. DNS. Alright, so click here. Okay, so DNS. And come here, click on go. So what I'm thinking is the issue here, why DNS is not showing us anything right here, right now, is because remember we had one promiscuity or promiscuous promiscuous not allowed for any devices. So it cannot gather or access or analyze traffic from any other place, any other network other than where it is, other than the network where we are working on. So if the promiscuous was allowed, the promiscuous setting was allowed, it would have gone ahead to check for other network traffics and then gather the information. But since we didn't allow that, it wasn't allowed for this. Remember, we saw something like that. So that's why this DNS is not showing. So the next thing I want to check for is loss of packets. Let's see if there were any packets lost. So I'm going to use TCP. I'm going to filter TCP dot analysis. Typing. Okay, let's give it some time. TCP dot analysis. Let me just type dot analysis. TCP.analysis retransmission. Okay, let's click on go. See. Okay, this too is not showing anything. So it's not showing anything. So no packets were lost. Okay, so finally I'm gonna check for, let's calculate for round trip time. Go back to ICMP. Round trip time, the time it took for the request. So this the time it took between when the request was sent to when there was a response. That's round trip time. Okay, so you can see there are not much difference in time. Alright. So basically this is it. Those other things did not work, especially the DNS, because of the promiscuous setting that wasn't allowed. Okay, so that will be it for today. I hope this helped.